I've had a few messages asking about residual pump head and pump selection, so I thought I'd take a bit of time to try and explain a little bit of the theory behind selecting pumps and why I'm choosing to use hydraulic separation in some instances in regards to insufficient residual pump head. So this is a quick sketch I've done from off of the internet of a pump curve, and the one on the Grundfos website seems to be covering a 1560 and 1550 pump in one set of curves. So I'm not entirely sure of which bit's which, but really the video is only for the theory. It's we could clarify which wins which at a later date. So if you look at the pump graphs, we need to know why, what they mean, and why we need to select from the pump chart. So further back in the design process, before we get to the stage of selecting the pump, we actually calculate the mass flow rate for the system, and we also calculate the resistance to flow of the circuit, of the index circuit, and also we take into account the resistance of the heat exchanger. And what we do, we come up with a set of readings. So one is the mass flow rate, so that'll be in usually for pump selection cubic meters per hour, and also resistance to flow in meters head. Once we have those figures, we look at our pump graph. So I'm going to go through residual pump head a little bit, and there's going to be two pumps we need to look at on the last half of it. We're going to find out that our mass flow rate for the boiler I'm going to use in my example is 0.75 something or other cubic meters an hour. And that's going to follow this line. And there's going to be two parts to the system. There's going to be the resistance of a system, which will be 2.5 meters head. So this point will be the intersection point on the graph, and it will indicate that we can use a 1550 pump on setting 1 in order to overcome the resistance of our system. There will be a second part which is going to show a resistance through our heat exchanger of 4.5 meters at the same flow rate, so that's 0.75 something or other cubic meters. And that's going to show that we need a 1560 pump on setting 3 in order just to overcome the resistance in the heat exchanger. I'd just like to cover a little something back on here. People have been talking about balancing systems, and a little bit concerned about the method, and they're using DT and mean temperatures, and this really isn't quite the full story. So if I give you an example, if the pump isn't suitable for the system, and it often isn't, you can actually get the radiators balanced, and you can get equal DTs across the radiators by going across and adjusting them, but you will not have the right flow rate and the right heat output through the radiators. And that's simply because all you're doing is you've got a reduced flow, and by balancing in that way, all you're actually doing is sharing the reduced flow across those radiators. You're not actually getting a proper flow rate through each one. So it would be very, very important to know that you actually had adequate flow available from the pump, or excess flow available for the pump at a pressure above the resistance calculated for the whole system before you started balancing down. And for this reason, lots of people are saying, well, I've never had a problem, I've always managed to get my radiators to work, you know, and I don't think hydraulic separation is necessary. Well, I'm sorry, but they're often wrong. And in fact, they did need hydraulic separation. All they've done is balance the system and reduce the output of their radiators. You know, you're going to get some clues back at the boiler here. So if you haven't got adequate flow through the system and you actually get a full load situation, your delta T here is going to start getting bigger. So this is going to be a good clue. If your DT can't be got correct here, under full load situation, then all you've actually done is spread out an incorrect flow rate across the system. And this is going to be very hard to do because it needs to be done under full load circumstances, and that means full output of the boiler. And it's very hard to get full output of the boiler and full output of the radiators to run while you're commissioning. unless you've got the design criteria delta T between the inside temperature of the room and the outside temperature of the property. And so, right, that's about all I'm going to get to be able to download on one video, so I'll have to do a new video for the second half.